Alright, here we have today is the Archimedean property, which is another direct consequence of the axiom of completeness. So the Archimedean property states that 1, given any real number x, there exists a natural number n satisfying n greater than x. And the second part states that given any real number y greater than 0, there exists a natural number n satisfying 1 over n less than that real number y. So the first part of the Archimedean property is basically saying that the natural number is unbounded above. So if you think about it, given any x in the real number, we can always find a natural number that is greater than that. So we are basically saying that the natural number is unbounded above. So the proof goes like this. Proof 1, our claim is that n is unbounded above. And we will actually use a proof by contradiction to show that one is true. So we will assume for contradiction that n is bounded above. By the axiom of completeness, since n is bounded above and non-empty, we can let alpha be the supremum of the natural numbers. Well, what do we know about alpha? We know that alpha minus 1 is not an upper bound for n. So there exists n in the natural number satisfying alpha minus 1 less than that n. And this is simply just the lemma that we have proved before. From this inequality, we can get alpha less than n plus 1, but obviously n plus 1 is in the natural number. So we are saying that alpha is less than some natural number, meaning that alpha is not an upper bound for n. Well, this is a contradiction since we assumed alpha to be the supremum of the natural numbers, but at the same time we're seeing that alpha cannot be an upper bound for n. Hence a contradiction. Alright, so that's the first part of the proof. What about the second part? Proof part 2. Let y greater than 0 be arbitrary. Now, proof of the second part is just going to follow the first one. Let's let x be 1 over y. Then by 1, there exists a natural number satisfying n greater than x, which is simply 1 over y. Well, this inequality implies that 1 over n is less than y, which is what we wanted to prove. So that's it. That's the Archimedean property.